As part of this course, we'll be using Express for the backend. As we will be using Express quite extensively, let us understand some key concepts and features provided by Express. You can click on this link for the official documentation of Express, and you can actually navigate through this and understand different aspects of the documentation. You can go to Getting Started and understand how to install Express using npm, hello world, using official Express generator to set up the skeleton, the information related to basic routing, how to handle static files if you are actually dealing with end-to-end web application or mobile application using Node.js, so on and so forth. To get into the detailed documentation with respect to different components of Express such as routing, middleware, error handling and debugging, you can go to this guide and you can choose the appropriate guide, and you should be able to understand details related to all these different components that comes as part of Express. Also, there is a section called as database integration. You can check this and it will give you a high level overview about how Express can be used to integrate with the database, and we'll actually get into those details when we talk about integrating MongoDB with Express to build full-blown backend application which will serve the REST APIs that are requested from the front end. You can also go to the API reference here and then advanced topics, resources, so on and so forth. That being said, let us understand how Express is used in real world. It is used to build end-to-end web applications with EJS or Pug-based views. It is primarily used for prototyping of web or mobile applications. There are even some production scale applications. However, they are typically applications up to medium level of complexity. If we have to build fully scalable enterprise scale application, then we have to come up with the architecture where the front end and back end are clearly separated and communicated via REST APIs. In those scenarios, we should not be using the view layer of Express. We can also build REST-based backend application for highly scalable web or mobile applications. The front end is typically built using Angular or React, which can talk with Node-based backend via REST. There are several popular frameworks listed here that are built on Express. One is Mean, where we have MongoDB, Express, Angular, and Node. It's a opinionated full-stack JavaScript framework that simplifies and accelerates web application development, and it uses Express as one of the key component for the backend. For the front end, it uses Angular. For database, it uses Mongo, and for the server, it uses Node. Like this, there are other popular frameworks also. You can actually go through this list and understand what all frameworks that are built on top of Express. Now let us understand the features and capabilities of Express. We can take care of routing. Routing is nothing but serving the endpoints. For each and every endpoint, there should be routing defined. Again, as part of that routing, we'll be serving the requests such as HTTP, put, post, delete, etc. So routing is the integration point between the REST request and the backend, and depending upon the endpoint and the type of request, we'll be invoking methods, and those methods are typically modularized under controller. We'll actually get into those details at a later point in time. On top of routing, it also have middleware. For example, once the request comes, we might want to perform sequence of actions. We might want to validate whether the information is passed to register a customer into our database completely or not, and once the validations are successful, then only we want to save into the database. As we have multiple actions that needs to be performed before saving the customer into the database on put or post request to add customer to our application, we have to implement this middleware concept that comes as part of Express. We'll get into those details at a later point in time. For now, just understand that there is a feature or component called as middleware as part of Express. And this middleware can be built either on router on the Express application completely. We'll actually get into those details very soon. On top of this routing and middleware, there is also something called as template engines. It is typically used for UI. There are two template engines it will support out of the box. They are nothing but EJS and Pug. You can use whatever is comfortable for you to build the view layer on top of these Express applications. If your application is serving REST APIs, typically you will be using send, and you will be sending a JSON object to the front end from where you got the request. If it is a full-blown full-stack application where you have view layer also, when we are actually serving the request, we'll use render on top of response, and we will be able to render using the templates that are defined in the view layer. However, we will not be getting into template engines as part of this course, because this course is not for end-to-end applications using Express. It is primarily to serve the REST APIs, and hence we will not be covering anything with respect to template engines for UI. Also, Express have robust error handling and debugging capabilities. You just have to understand appropriate APIs, and we should be able to take it from there. We'll be spending a good amount of time on routing. Routing typically takes request and response as arguments. So let's start and then let us understand how it works. In this case, I'll be adding an API called as use. Here, app is of type Express. You can see that I'm invoking Express constructor here and creating this app object, and Express is nothing but the module which is imported using this piece of code. So when I pass a customer endpoint with ID, I want to read the customer information from the database and return that as response. So here this app.use takes second argument, which is nothing but a function. Here I'm using a arrow function where I'm passing the request and response directly. And then we will come up with the logic to query the database and get the JSON as response to our HTTP request. So you can actually come up with complete business logic here itself. However, this is not a good practice. We should modularize. However, we will get into the modularizing at a later point in time. That being said, as we want to integrate with the MongoDB database, first we need to ensure that Mongoose is already set up. You can go to package.json and you can see whether Mongoose is set up or not. It is already set up. Once we confirm that, we will actually import Mongoose like this. Once it is imported, we will actually create Mongo URL. In this case, I'm hard coding. Typically, we should not hard code like this, but we will see those details at a later point in time. To keep it simple, we will just hard code like this. We'll be using retail database, and hence I'm saying /retail here. Once you have this, you can say mongoose.connect. You can pass Mongo URL and then properties such as use new URL parser with true. Now we have the logic to establish the connection with the MongoDB database. Using this Mongoose, we will also create the model after creating the schema, and we'll use it to query the data from the database. So to create the model, first of all, we need to understand the data that is already stored in the database, and hence I'm going to Mongo and then to retail. We have customers collection. We can say db.customers.find1 and hit enter. We can take this and then we can say const customer schema equal to mongoose.schema, and then right click, fix ESLint problems. Okay, there seems to be some typos somewhere. Yeah, there is one more additional curly brace here. I just have to delete that. And then I can say fix ESLint problems here. We don't need ID. Customer ID is of type number, so we have to say type number. It is required, and hence required is true, and then unique is true. So like this, we have to define data type and other properties for each and every field that is part of our customers. First name need not be unique, and hence I'm removing this, and it is of type string. Last name, email, password, street, city, state. Even zip code will be storing as a 5-character string rather than 5-digit number, and hence I'm defining it as string. I want email also to be unique, and also I want to store email IDs in uppercase only. So I can say uppercase true. As we got the schema, now we can actually say const customer model equal to mongoose.model. Customer is the name of the model. We'll be using customer schema, and the collection in the database is nothing but customers. Now as we have the model, we can actually say customer model find one. So here we need to pass the condition on which the data should be fetched. We want to get based on customer ID, which is passed as part of the endpoint. This can be accessed using the request.params. So I can say customer ID request.params.id, which will give whatever ID is passed at the runtime. Then we can actually say exec to execute this query. It returns promise, and we have to come up with logic for on fulfilled using then, and catch can be used for on rejected. So as part of the then, we will actually get the object from the query. Here we just need to say rest.send customer. It will return the JSON as response to our request. Similarly, when it comes to catch, we just have to throw error. We might have to deal with error handling in a different way. We'll see that at a later point in time. For now, we'll just throw error like this. Now you can save this. And when we actually start using npm and then go to the browser and pass customer with ID, it should be able to connect to the database and get the JSON object as response from the database. So let's go ahead and validate, and then we'll actually go through the concepts related to routing so that you understand whatever is specified as part of the reference material. So I'm coming out of this Mongo. We have customer ID 4 here, so we'll be using the same. But before that, we have to say npm start. Let me make sure that I'm in the right project directory. If you are not sure, you can actually right click on this copy path and then say cd paste and hit enter. Then you can say npm start and hit enter. As there are no errors here, now we can go to the browser and then we can say localhost 3000 customer 4 and hit enter. You can see the information for customer ID 4 here. So this is how you can actually serve the GET request. We will see other details also at a later point in time. Now if you go to the material, typically routing takes request and response as arguments. So in this case, we are defining the route here. On top of the request, we are also passing request and response as arguments, and we are coming up with the logic here. So here we are using arrow functions. This is same as saying function like this, which is a callback approach, and then coming up with the logic. However, with ES6, we should be using arrow functions like this. These are also known as anonymous or lambda functions. Okay, so we have request as well as response. REQ stands for request, RES stands for response. Request object exposes several APIs which are helpful in dealing with request URLs. We can pass and extract information from URL using rec.params. We can also pass the body into JSON or object using rec.body. This is typically used as part of post or put requests, where we want to pass the entire customer information to be saved into a database or updated in the database. And then when it comes to result, which is nothing but RES, it exposes several APIs to send response back to the request. In this case, these are standard names which we typically give for the arguments. You can give whatever names you want. You can just say R1, R2, or you can say request, comma, response, or whatever name you want to give to these arguments, you can give them. Irrespective of the name, the first argument is request and the second argument is response. So for response, it exposes several APIs to send response back to the request. We can use res.send to actually send the response as JSON to the requested frontend. We can use res.render if you are using a template engine to render the pages based upon the information that is fetched from the database. Then we can use res.render and we can actually pass a JSON or object to it, and it will actually pass that and it will take care of rendering on the browser. You can also say res.redirect. Like this, there are several other APIs. I have already mentioned about middleware. It can be used to chain the sequence of tasks. For example, if you want to add a customer, we might want to perform validations and then save into database. So in this case, instead of directly saving into the database, we might want to perform certain validations. And when these validations are involved, it is better to modularize and define different functions, and we want to execute these functions in sequence. So we don't need to worry too much about writing the logic to invoke the functions if we use Express middleware. It have an additional argument called as next, and that next will give us flexibility to actually trigger the next function in the sequence without giving any names to the functions. We'll actually explore those details when we talk about a proper use case, when we start performing advanced operations at a later point in time. When we use middleware, Express will ensure that all the functions are called in sequence fashion, while individual function might run asynchronously. So if you are using middleware and if you have 10 functions, all those 10 functions will be invoked in sequence in synchronous fashion. However, within each function, the operations are typically asynchronous. So you need to keep this in mind. Again, if you don't understand it, that's fine for now. We'll actually get into those details when we talk about middleware using proper examples. For now, we'll be focusing on performing CRUD operations for customer management. We'll actually go to order management and dashboard as part of next major topic, where we'll be covering middleware a bit in detail. Before we get into customer management using CRUD operations, let us understand that this is not good practice to have the business logic as part of app.js. We need to modularize the code. As part of the modularizing the code, we need to have model. As part of the model, we will have the schema and model, and then we need to have controller. Controller will have methods such as add customer, update customer, delete customer, get customer details, etc. And we'll have the business logic with respect to validations before performing the database operations, and then returning the proper response to the request. When it comes to mapping between the endpoint and these functions that are part of controller, those should be placed in a file called as router. Typically for each route, we'll have a file, and that file will have all the possible endpoints, and those endpoints will be mapped to the methods that are part of the controller. We'll be importing the controllers as part of the routers, and we'll be invoking the functions based upon the endpoint which we are trying to use to submit the request. And then in app.js, we'll just have the logic to establish connection with the underlying database, which is MongoDB in our case. And also, it will actually have a mapping at a higher level API with the router file. So in our case, we'll have a router called as customer router, which will have all possible endpoints mapped to methods in controller, and the controller will have the business logic and the logic to perform the database operations. However, at a higher level, we'll be using customer as route, and that mapping between the router file and this high level endpoint customer will be defined as part of app.js. We will see those details as we proceed further. We'll first modularize the code where we'll be having customer router, controller, and then model, and then we'll come up with the CRUD operations using get, put or post, delete, etc.